I wanted to make a video about understanding intercepts and asymptotes of functions, and I didn't want to do it in the context of specific functions, but functions kind of in general. And so here's a really strange function I created, f of x. Do you see how there's only one y-intercept at 0, 5? Of course, all functions have at most one y-intercept. It also has 3 x-intercepts where it crosses the x-axis. It's got a horizontal asymptote at y equals 2. That's where the graph kind of levels out. It's on the left. If you're coming down to the left, it levels out at 2. On the right, if you're walking on it, it levels out at 2. That's what a horizontal asymptote is all about. And then the vertical asymptote is x equals negative 5. Let's look at the y-intercept first. The key thing is, do you see that the y-intercept has an x-coordinate of 0? And that's always true, because every single point on the y-axis has a x-coordinate of 0. And that's just exactly how you deal with them when someone asks you for a y-intercept. You just plug in 0. The key thing is, don't memorize this idea, understand it from the picture. Now, what about x-intercepts? We've got 3 here. Again, what's similar about them all, they all have a 0 in the y-coordinate. And same reasoning, no matter where you are along the x-axis, your y is going to be 0. And so x-intercepts happen when y is 0. Again, don't memorize this. Just make sure you're understanding it. Now, the horizontal asymptotes are a little harder to talk about. What does this y equal 2 mean? And so I went ahead and zoomed out. So right now I'm just looking from negative 20 to, it looks like 14. Let me zoom out. Here I'm looking from negative 200 to 200. Again, it's really leveled out at 2. There's a whole bunch of kind of crazy stuff going on in the middle, but you don't care about that with horizontal asymptotes. You care what's happening out on the edges, far, far away from the origin. Let's zoom out a little bit larger. And now I'm going to negative 2,000 and 2,000. Again, you've got it leveling out, and you can barely see the craziness. We're so far away, the craziness of the middle is not easy to see. And that's why the horizontal asymptote is y equals 2. Because when you look at it from far, far away, it pretty much looks like the line y equals 2. Okay, and lastly, this vertical asymptote of x equals negative 5. That almost always deals with having a domain problem in the denominator when you have an asymptote. Not always, but at least for the functions we know right now. And so it implies there's an x plus 5 in the denominator. So let's look at some examples. And I made that spin because it's very important to not memorize these things. I want to talk about the y-intercepts. Remember, the y-intercept happens when x is 0. So we really just want to plug in 0 for all the x's, like every single x on all the different functions. When you plug in 0 to g, you get negative 48. 0 to h, you get 100 over 289. Such a beautiful number, etc. When you plug 0 in for k, you end up with a 16 in the square root. You'll end up with 2. And of course here, you just end up with 13. So our y-intercepts are these 4 points on the different functions. Now, y-intercepts are the easy ones. X-intercepts are a little bit harder. But again, let's remember that x-intercepts happen where the y value is 0. So we pretty much want every single function to equal 0 when we're looking at them separately. We're going to want to solve these 4 equations. Now, this one is factored. It's very easy to set it equal to 0, and we're going to get 4 and negative 2. For this one, the only way for a fraction to be 0 is if the numerator is 0, right? Having a denominator be 0 is bad. So we're going to have 2 answers there, negative 5 and 4. For this one, the only way for a fraction to be 0, again, is if the numerator is 0, and that's not ever going to happen. So that one has no solution. And if we try to solve for x here, we're going to end up with negative 13 equals 2x to the 4th. The 2x to the 4th is always positive, or 0 at the least. So no solution there. And what that means is g and h both have 2 x-intercepts, and k and w don't have any x-intercepts. Okay, now to the vertical asymptotes. Again, vertical asymptotes is about a domain problem. This one's not going to have any domain problems, so there will be no vertical asymptote. This one won't either. No domain problems. The only domain problems is going to be right here. We're not allowed to have that be 0. Also here, we're also going to have to worry about it being negative inside that square root, but 0 is going to blow it up. So again, vertical asymptotes, what I'm talking about is what I've highlighted there. Like I said, this one has no domain issues. Here we want to solve when the denominator is 0, and here we want the inside of that square root to be positive. And it turns out that as long as x is greater than negative 17/4, it's going to be positive, but it also implies that negative 17/4 is bad. So the G, there's no vertical asymptotes, no domain problem. H, the domain problem happens when the denominator is 0. That happens at 2 and 17. K, your domain is going to be 0 when x is negative 17/4. And W, there's no vertical asymptotes on that one. Okay, lastly, horizontal asymptotes. That, again, happens when you plug very large values in. So notice when we were playing with our function f, we were plugging really large values, and even those aren't that large. So, for example, G, I plugged in negative 100 and got negative 3 million roughly. I plugged in 100 and got positive 3 million. It's not really leveling out, so there's not a horizontal asymptote there. But when I plug in big numbers for H, x equals negative 1,000 and x equals positive 1,000, do you see how they're both really close to 2? This is not an exact way of understanding it, but it kind of helps us understand the meaning behind it. The whole point there is when you plug in really large numbers, you roughly get 2. So that means that the horizontal asymptote is y equals 2. And here are big numbers that I've plugged in for k. We'll talk about them in a second, and the same thing for w. And let's talk about what that means for both of those. So for k, you see how it's getting smaller and smaller, but it's not ever going to be negative. That has a horizontal asymptote at y equals 0. It's getting closer and closer and closer to 0, where the one on the right, w, if you look, this is actually quite large. This is quite large. This is even bigger. This is even bigger. It's not leveling it off at all. There's no horizontal asymptote there. I know it's kind of silly if you understand the functions for me to even ask about horizontal asymptotes on this one and this one. But still, it's kind of nice to look at all the different things you can do with a graph for all sorts of different types of functions. Sometimes it helps understand what a horizontal asymptote is when you understand what one is not.